Mac. Assalamu alaikum and greetings everyone. We are Group C2G01 from the course Capstone project SKE 4723 and our topic for the project is a smart agriculture system where we chose to work on the aquaculture field. We are a group of 4 members and our group members are Alexander Anderson, Anak Anthony, Nick Marisa binti Nick Mazlan, Ahmed Fadila bin Pitkari, and myself Adi Muhammad. We are under the supervision of Dr. Nurul Muazza binti Abdul Latif. In this presentation, on the basis of our project, we'll be presenting the method of data collections, our findings from data clustering, user profile, design statement, steep analysis, conceptual prototype, conclusion, and references. And we have come up with a product which we call it MAC, Monitor, Analyze, Quality. In order to collect data based on which we will be developing a product, we carried out interviews among local fish farming companies all across Malaysia. We interviewed companies from Kelantan, Selangor, Kuala Lumpur, Negeri Sembilan, Sabah, and Sarawak. Our mode of conduct for the interview were of 4 types: phone interview, face-to-face interview, online interview, and questionnaire from Google Form survey according to the company's preferences. By the 4 mode of conduct of interviews, we interviewed 12 companies in total. About 58.33% of the data were collected from Google Form survey, 16.67 data collected from face-to-face interview, 16.67 data collected from the interview over direct phone call or WhatsApp call, and 8.33% data from online interview. The first question we asked was what type of fish they are farming, and based on their answers, we saw about 33.3% of the companies cultivates saltwater fish, 58.3% of the companies farm freshwater fish, and 8.3% of the companies farm saltwater shrimp. Next, we asked about the location of their fish farms and whether their farms are indoor or outdoor bases. From the data, it seemed that most of the companies we interviewed are from Sabah, about 41.7%, and Sarawak, 25%, and mostly their companies are outdoor bases. Then we asked how long their companies are running business or have experience in the fish farming industry and whether they are small scale, medium scale, or large scale industry. And it seemed that most of the companies have 5 to 10 years of experience and most of them were a small scale industry. From these questions, we were able to generalize the type of customer we would be targeting for the basis of our project. The next question we asked is what significant obstacles these companies encountered in order to know the problems they're facing. 75% said inconsistent pH, temperature, and predator problems. 25% said natural disaster, water contamination, and infrequent and inconsistent maintenance. 16.7% said security problem, power outage, and 8.3% said labor monetary problems are what they're facing. Next, we asked the companies if they're already using some sort of technologies, what barriers they face to fully adapt to those technology. In other words, what are the things their technology lack of? 83.3% said cost was a factor, 41.7% suggested their technology requires strict maintenance and supervision, while others said adaptation accessibility was not favorable and the system wasn't portable and often not properly used. So based on the data we collected from different interviews, we clustered them into 3 categories, which are pain points, that is problem faced by the companies, the technology the companies were using, and parameters that these companies needed to measure to keep their fishes healthy. Then we circled around the frequency of the occurrence from the pain points to know which problems fish farmers faced most and then jot them down all in a table. These are some of the technologies the company said they are already using, and these are some of the suggestions the company said they prefer to have in a new technology. From these suggestions and based on our ability, we picked out auto feeding system and water quality monitoring system to be the key features of our product. From our choices and findings from the cluster data, we come up with the user profile. Jeep is a 35 years old aquaculture farmer who runs a small-scale fish farming company, and since it is a small-scale company, it uses fewer manpower to keep an eye on the farm. However, because his farm is far from his house, he cannot keep balance between his career and family. Now what he needs is a device that is portable that can monitor the quality of the water, which he can remotely supervise using an app. The device can run on solar energy and is affordable. The reason why he needs such a device, or in other words, the pain points are his farm maintenance is not consistent, and so a lack of supervision and water condition hardly remains at its optimum level, which leads to the fish having disease. So based on that, we come up with a design statement that how can we help Jeep to have an affordable monitoring system of his aquaculture farm with app supervision. Hence we decided to develop a device that would be portable, affordable, can monitor the water quality supervised using app, is powered by solar energy and has additional feature of auto feeding system. We also carried out steep analysis to bring forward the external factors our product can have an impact upon. So on social ground, it will let more fish farmers to switch on remote monitoring and controlling of their farms. In terms of technology, we're developing a combination of smart feeding and monitoring system and IoT is integrated. The product would cost less than 200, so quite affordable and economically beneficial. It is environment friendly since it would run on solar energy, which reduces carbon footprint and will be made of recycled products. On political grounds, such a product would lead to the development of fish farming in Malaysia since IR 4.0 is implemented, as well as in the progress of Dasar Agromakan Negara policy, since this device would ensure good quality fish farming and production.
In seabeds or known as ikan siakap was due to the opening of all post-COVID economies. The cost of RM 6,000 per kilo has caused some customers to complain.
Saya Pak Cik Jip. Harga ikan siakap ni makin tinggi. Bukan saja ikan siakap, ikan lain-lain pun sama. Pertama, sebab lepas COVID ni, susah nak cari buruh nak jaga kolam. Kedua, sebab ikan ni kadang-kadang mati, kadang-kadang ada yang hidup. Sebab cuaca tak menentu, jadi kualiti air tu bagi kesan lah.
However, 4 UTM students have successfully produced a prototype to solve this problem. We are with Mr. Capstone on the screen.
We are confident of helping by producing monitoring system and automated feeding system for the fuel fish pond. Let me explain more about the system with illustration.
This device measures the water pH, temperature, and turbidity and provide an automatic feeding system. The sensor will be located below the polystyrene. The feeding system will automatically feed the fish at the time set by Pak Cik Jip. For example, he set at 8 AM, 12 PM, and 10 PM. As we know, wireless made simple, so the system is powered by a green energy, which is lithium battery and a solar panel, and he can monitor his farm through his phone. So, let's go into detail how the system works. Initially, the system will inquire what is the current time. The RTC will then provide the system with real-time information. It will only monitor pH, temperature, and turbidity if the time is not the same as the set time by Pak Cik Jip. When the sensor detects the parameters are outside the range, a buzzer, a red LED will light up, and a notification through the apps to notify there is problem. When the system is in range, a green LED will be illuminated. When the time is now is the same as on the set value, the system will monitor the pH of the water, and if it's at an optimum level, it will activate the servo motor to open the food tank feeding port. The food fish will come out of the feeding pot and fall into the water. A buzzer, a red LED will light up, and a notification through an app to notify Pak Cik Jip if the pH level is not optimum, perhaps due to the water quality level or uneaten fish food. In addition, the servo motor won't work since the pH level isn't ideal. Keep in mind the pH level of the water will drop if there is a lot of uneaten fish food. The ultimate promise of the Mac is to make you the master of your farm that you can control and monitor.
Experience digital with us. All you need is fish with Mac.